Hello everyone, I'm Yiqin from HCI Lab of Tsinghua University. Today I will introduce our paper, Designing and Evaluating Hand-to-Hand Gestures with Dual Commodity Wristband Devices. Nowadays, smart wristband devices are widely used in our lives, such as smartwatches and smart bands. They are liked by users because of their key features. For example, they are wearable, they have rich functionalities, they are always on, and maybe they lead to new fashions. These devices do a lot of things like notification, step counting, and monitoring the health. Many previous researchers have investigated the possibility of sensing hand gestures using commodity wrist-worn devices. Most of them are embedded inertial sensors, microphones, or PPG sensors. However, these works focus on sensing with one device. So what about two devices? In this paper, we introduce a new interaction called hand-to-hand gestures. That is, the user touches one hand to another hand to make a motion, which can be sensed by two wrist-worn devices. The devices recognize the user's intention and send a command to the phone via Bluetooth to trigger some functions. Audience may have three common questions, so let's go to the first question. What's new when sensing with two wrist-worn devices? Look at this palm-to-palm gesture. I identify the orientation of hands by three axes. Different gestures may have different orientations of hands. Look at details. Assume the orientation of the left hand is QL and the right hand is QR. When doing the same gesture like this, there will be a constant rotation between QL and QR. We call this relative rotation delta Q. When doing a motion, there will be a mutual motion M and a minus M on each of the left and right hand. Then ideally, ML and MR will have the strong negative correlation, and we can use dot products to calculate this correlation. So there will be some new features combining data with two devices, like relative rotation and correlation. That's our answer to what's new. Let's move to the second question. Which hand-to-hand gestures are usable and preferred? We did a preliminary interview. Here are some key findings. Hand states like open hands, closed fists, or one finger extended should be differentiated as different gestures. Touch areas like palm, hand back should also be regarded as different. On the other hand, palm-to-palm gestures with different directions should be regarded as the same gesture. Finger states like flexion or relaxation and intensity should also not be differentiated. Then we derive a design space considering the dominant hand, the non-dominant hand, and their motion type, tap or swipe. We propose 41 tap gestures and 15 swipe gestures, like the right picture. We also collected users' subjective ratings on these gestures based on the usability, memorability, social acceptance, and disambiguity. For details, please read our paper. So the last question, how this interaction works in real scenarios. We use two SVM classifiers to detect and recognize data. Features include statistical features of single initial data, acoustic features from macro data, and new features of dual initial sensors, like a correlation and a relative rotation. We propose two gesture sets, 10 gestures for a stationary condition and 5 gestures for walking and running condition. To validate the performance of our algorithm, we collected 50 samples of each gesture and ambient hand motion as noise for training and testing. Results showed both detection and recognition accuracies are very high. Compared with only one you use only one device, like a left device or right device. Using dual devices provide more sensing capabilities and achieve higher sensing performance. Then we implemented our model into a real-time system and evaluated the hand-to-hand gesture interaction in real scenarios. Here is the mapping between real smartphone tasks and gestures. Our experiment in real scenarios also showed that our system achieved about 90% task success rate, which means it works for remote triggering of the smartphone. Beyond this paper, we can envision future works, like exploring more gestures which don't need two hands to touch each other, or when wrist-worn devices contain more technologies. What role can dual devices play in gesture sensing? Okay, that's all on my presentation. Thank you for listening.